We can carry out a very similar calculation at point B. Now let's recall at point A we calculated the force to be, or the electric field to be 68 kilonewtons per coulomb at an angle of 29.7 degrees, and this is the electric field at the point 0.7 meters, 0.4 meters, due to a 5 microcoulomb charge at the origin. Point B is at 3 meters and negative 4 meters in the x and y directions. And we make a very similar calculation at point B. The calculation gives us an electric field of kq over r squared, 180,000 newtons per coulomb. The angle is the inverse tangent of the negative 0.4 over the 0.3. Just think of the triangle here. And the vector, of course, is in the direction of the hypotenuse of that triangle. This inverse tangent is negative 53 degrees, so this is negative 53 or 307 degrees, depending whether we measure it in the negative direction or the positive direction from the positive x-axis. Recall the general definition of the force vector. This allows the calculation in a fairly straightforward manner. If we just want to do the calculation, we just plug the kq1 qt over r squared, where qt is a test charge, in, and we get the force between the 5 microcoulombs and a test charge at point B. Then we multiply by the unit vector r over magnitude of r. This is the unit vector that corresponds to the vector from 0, 0 to 3, negative 4. We just take the vector from 3 with components 3, negative 4, and divide by the magnitude, which is 0.5. The vector is 0.3, negative 0.4. We divide by the magnitude 0.5. We get a unit vector. It turns out to be have components 0.6 and negative 0.8. We could multiply that by the force that we get here to get the vector force, and then we divide that vector force by the test charge qt, and we get kq1 over r squared times the r over magnitude of r. If we just look at this symbolically, if we divide qt in here, we get all the same stuff. We just don't get the qt because it divides out. The magnitude of the force, or the electric field, of course, is kq1 over r squared, where r is the distance to the point.